We now look at when the comparison functor K is an adjoint. We fix an adjoint situation Fg and set T to be the monad induced by it. Then we recall that the comparison functor K is the unique functor from A to the Eilenberg-Mohr category such that Kf is equal to Ft and Utk is equal to G. We will use a few results from the playlist on adjoint situations. First, recall that K is adjoint if and only if for each Eilenberg-Mohr object x theta, the category x theta over K has an initial object. Then from the universal mapping property of the initial object, we can construct the left adjoint L, the unit, eta bar, and the co-unit, which is the unique amorphism from LKA to A such that K epsilon bar A, eta bar Ka is the identity on Ka. These results are proven in the video. Adjoints are determined by universal properties of the unit. The second result we recall is that if Lk is an adjoint situation, then LFT UTK is an adjoint situation, where the unit H is given by UT eta bar Ft eta, and the co-unit E is given by epsilon bar L epsilon T K. This is covered in the video Adjoints are closed under composition. We also have 3 that if Lk is an adjoint situation, then since UTK is equal to G, we have LFT, G is an adjoint situation. And then since Fg is an adjoint situation, we have that there exists a unique natural isomorphism alpha from LFT to F such that epsilon alpha G is equal to epsilon bar L epsilon TK, and G alpha UT eta bar FT eta is equal to eta. This is covered in the video Adjoints determine their coadjoint pair. And finally, we note 4 that if Lk is an adjoint situation, L preserves coequalizers. This is covered in the video Adjoints, coadjoints preserve limits, colimits. So now we're ready to prove that the comparison functor K is adjoint if and only if for each Eilenberg-Mohr object x theta, the coequalizer of epsilon fx and f theta exists in A. To prove the forward direction, we let Lk be an adjoint situation. Then by 2 and 3 above, there exists this unique natural isomorphism alpha from LFT to F, such that G alpha x UT eta bar FT x eta x is equal to eta x for each x in E. Therefore, by the isomorphism on Hom sets induced by the adjoint situation, we have eta x being taken to the identity on kfx, but eta x is equal to this expression, and so we have the isomorphism taking this to epsilon t ft x ft on the original expression here. And this is also the identity on kfx. But note that this composition can be reduced by using the naturality of epsilon t to k alpha x eta bar ftx, and therefore this is equal to the identity on kfx. But by 1 above, the co-unit of the adjoint situation, Lk, at component fx, is the unique amorphism epsilon bar fx, such that k epsilon bar fx eta bar ftx is equal to the identity on kfx. Therefore, alpha x must be equal to epsilon bar fx. Then since alpha x is an isomorphism, epsilon bar fx is an isomorphism. Then by 4 above, we see that L preserves coequalizers. Therefore, the following is a coequalizer diagram, since theta is the coequalizer of mu x t theta. And note that L mu x is equal to L ft epsilon fx, and L t theta is equal to L ft f theta. Then we take the parallel pair epsilon fx f theta and use the isomorphisms epsilon bar fg fx and epsilon bar fx to show that the parallel pair Lk epsilon fx and Lk f theta is isomorphic to epsilon fx and f theta. And finally, we note that Lkf gfx is Lft tx and Lkfx is Lftx, since kf is equal to ft. And also Lk epsilon fx is equal to L mu x, and Lk f theta is equal to Lt theta, since K is G on morphisms. So the yellow parallel pair is equal to the top blue parallel pair, and hence the bottom pair is isomorphic to the top pair. Thus, as colimits enjoy universal mapping properties up to unique isomorphisms, we see that L theta alpha inverse fx is the coequalizer of epsilon fx f theta, which completes the proof for the forward direction. Conversely, using 1 above, it is enough to show that for each Eilenberg-Mohr object, x theta, the category x theta over k has an initial object. By assumption, there exists a coequalizer diagram where q is the coequalizer of epsilon fx f theta. Then we apply the functor k to this coequalizer diagram, and then we note that the the objects in the red diagram, KFGFX and KFX, are equal to FT-TX and FTX by definitions of K and FT, and the morphisms K-epsilon-FX is G-epsilon-FX, which is the multiplication of the monad mu-x, and K-F-theta is G-F-theta, which is T-theta. Therefore, the light blue and red parallel pairs of morphisms are equal. Thus, by the universal mapping property of x-theta as the co-equalizer of mu-x T-theta, there is a unique factorization eta bar x theta from x theta to KL x theta. We claim eta bar x theta L x theta is the initial object in x theta over k. In other words, 1 for each x theta over k object f, there exists a morphism H such that KH eta bar x theta is equal to f. And 2, if KH eta bar x theta is equal to KH prime eta bar x theta, then H is equal to H prime. For 1 given f, we use the universal mapping property of Lx theta as the co-equalizer to show the existence of a morphism H. To do this, we construct a morphism FGFF and FF between parallel pairs on the left. We verify that the squares commute by naturality of epsilon on the left and the fact that F is a morphism in the Eilenberg-Moore category on the right. Then since epsilon FGA is equal to epsilon A FG epsilon A, by naturality of epsilon, this morphism on the left of parallel pairs induces a unique factorization H. We want to show that KH eta bar x theta is equal to f. To do this, it is enough to show that KH eta bar x theta theta is equal to f theta, since theta is a split epimorphism. Since eta bar x theta theta is equal to KQ by the definition of eta above, we get this equal to KH KQ, and we factor out K and use the equality HQ equal to epsilon A FF to arrive at K epsilon A KFF. But since F is a morphism in the Eilenberg-Moore category, this is equal to F theta. And so H is a X theta over K morphism. For the uniqueness part, too, we suppose that there is another amorphism, H prime, such that KH eta bar X theta is equal to KH prime eta bar X theta. By precomposing by theta, we have KHQ is equal to KH prime Q. Then noting that K is just G on underlying E morphisms, it is enough to show that GHQ equal to GH prime Q implies that H is equal to H prime. By using the universal mapping property of the unit eta, we see that in the diagram the bottom triangle commutes by the triangle identity for the adjoint situation FG, and the top square commutes by naturality of eta. And then since HQ is equal to epsilon A FF, we have the composition G epsilon A GFF equal to GHQ, which is equal to GH prime Q. Therefore, HQ is equal to H prime Q by the universal mapping property of the unit, and so H is equal to H prime by the universal mapping property of L x theta as the co-equalizer of epsilon fx and f theta. Therefore, eta bar x theta L x theta is the initial object in x theta over k, and thus k is a joint, which completes the proof.